Hello, welcome back. In our last class, we were discussing how the probability distribution of a function of a single random variable is obtained. There we were considering a random variable x, and we defined a transformed variable, a new variable y, that is equal to g of x, and we have considered different methods for finding the distribution of the new variable y, and there we have considered a method of transformation to find the probability distribution. And in that case, we have assumed that the function g of x is strictly increasing or strictly decreasing, or in general, the function g of x is monotone. Here, in this section, we shall consider the joint distribution of two random variables x and y, and we shall consider some transformation by means of functions g1 and g2 to define new variables u and v. So the new variable u will be a function of x and y, the original variables, and similarly another variable, new variable v, that is equal to another function of the random variables x and y. Okay, and then we will determine the distribution of u and v jointly, that is joint distribution of u and v, from which we can find the marginal distribution of u and marginal distribution of v. For that purpose, we assume that these functions, that is g1 and g2, are 1 1. They are 1 1 mapping of r square into itself. Okay, so range of x and y may be minus infinity to infinity for x as well as for y, and naturally the range of u and v also will be minus infinity to infinity, or sometimes the range of x and y may be some subinterval of minus infinity to infinity. For example, say the range for x is minus infinity to infinity, and the range for y may be from 0 to infinity, or x and y may be defined for any subinterval of minus infinity to infinity, and accordingly you can find the range of u and v. Okay, and the method of finding the range of the transformed variable u and v we will discuss in some examples. Okay, now the convenience of taking these functions g1 and g2 are 1 1 mapping. As a consequence, you will get the inverse functions g1 inverse and g2 inverse of u and v for explicitly expressing x and y. Okay, so from this transformations u and v, you can obtain the value of x and y explicitly in terms of u and v. Okay, and once x and y are explicitly expressed in terms of u and v, you will be able to find the Jacobian of the transformation. And for that purpose, you have to find the partial derivative of x with respect to u, partial derivative of x with respect to v, partial derivative of y with respect to u, and partial derivative of y with respect to v. Okay. In the case of a transformation, one-dimensional transformation, you know that the distribution of transformed variable can be obtained in terms of the distribution of the original variable multiplied by the modulus of Jacobian. You may please recall that result. And a similar result you will obtain in this case also. In order to find the joint distribution of transformed variables u and v, we have to multiply the modulus of Jacobian with the joint density of x and y with the arguments g1 inverse uv and g2 inverse uv, which are of course in terms of x and y. This argument is also in terms of x and y in general, and this argument is also in terms of in terms of in terms of u and v. Okay, and for that purpose you use the formula for joint density of x and y. That means if you have the joint density of x and y, you can find the joint density of the transformed variables u and v using the Jacobian of transformation. And in this case, the Jacobian of transformation is equal to the determinant of dx by du, dx by dv, dy by du, and dy by dv. All these derivatives are partial derivatives instead of total derivatives. And the Jacobian is always is not equal to 0. If the Jacobian is equal to 0, this procedure will fail. Okay. Okay, now you see how the computation is done. For the illustration purpose, I first consider an example. Okay, in this example, you see, you have two random variables x and y, which have a joint PDF fxy equal to e to the power of minus x. X and y varies from 0 to infinity with a restriction that y less than or equal to x. This is only an example. And this type of restrictions need not be there always. And this restriction actually implies that x and y, the random variables x and y, are not independent, because y is restricted to be less than or equal to x. Because of this restriction, you can easily conclude that x and y are not independent. And if x and y are independent, then this type of restrictions will not be present there. And you see, in this problem, you have to find the joint PDF of u and v, where u is equal to x plus y and v is equal to x minus y. This is only an example. So in the first problem, we will find the joint PDF of u and v, and as the second part, we will find the marginal PDF of u and v. Okay, you know how the marginals are determined out of the joint PDF. Suppose you find the joint PDF of u and v, you can find the marginal of u by integrating the joint PDF with respect to v, and the marginal PDF of v can be obtained by integrating the joint PDF with respect to u. This is a usual procedure, and you might have familiarity with this type of problems in your degree classes. And if you are not thorough with this procedure, you may please brush up with the degree syllabus and degree problems. Okay, in this example, you see the joint PDF is e to the power of minus x, fxy equal to e to the power of minus x in this range as given in this problem. Okay, and you have u equal to x plus y and v is equal to x minus y, because you are using the transformation capital U equal to capital X plus y and the capital V is equal to capital X minus y. Here you are using capital letters, whereas here you are using small letters. It is only because these are the random variables and these are the values assumed by the random variables, particular values assumed by the random variable. Okay, and you can see the range of v and u first. What is u? U is equal to x plus y and v is equal to x minus y. And since x and y varies from 0 to infinity, definitely u, which is equal to x plus y, will also vary from 0 to infinity. But since v is equal to x minus y, you cannot have u and v varies 0 to infinity. U and v, of course, varies from 0 to infinity, but there will be a restriction of this kind, v less than or equal to u, because u is always greater than or equal to v because of this x plus y and x minus y. Okay, so you have found the range of the transformed variables u and v. Okay, and next you have to explicitly express x and y separately in terms of u and v. And for that purpose you can utilize these two equations, u equal to x plus y and v is equal to x minus y. From these two equations you can definitely write x is equal to u plus v by 2 and y is equal to u minus v by 2. Okay, so x is expressed in terms of u and v, that is g1 inverse of u and v. And similarly y is expressed in terms of u and v explicitly, so this can be called as the g2 inverse of u and v, right? And you can find the Jacobian of transformation, that is equal to determinant of the matrix dou x by dou u, dou x by dou v, dou y by dou u, and dou y by dou v. Okay, and that is equal to determinant of 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. These derivatives you can easily found out from this formula x and y. You may easily check these things, and this becomes minus 1 by 2, and therefore the Jacobian's modulus, that is modulus of Jacobian, that is equal to 1 by 2. It is a positive number, right? Okay, now you can utilize the formula. What is the formula? You are using the formula FUV of UV equal to the joint density of x and y with the arguments g1 inverse of UV and g2 inverse of UV. You have found out what is g1 inverse of UV and g2 inverse of UV and Jacobian. So you substitute those things in this formula. Okay, now in this formula, you know, the formula is e to the power of minus x. Okay, e to the power of minus x, that is e to the power of minus, what is x? X equal to u plus v by 2 into Jacobian's modulus, and this is the range. So the main task you have completed, that is to express the joint density of transformed variables u and v. And from this joint density you can easily find out the marginal densities. How the marginal density of u is obtained? Yes, marginal density of u, which you represent as fu of u, that is equal to integral of the joint density with respect to v. Okay, and similarly you will see the marginal density of v as fv of v integral of the joint density with respect to u. Okay, this is the usual procedure. Okay, and you see what is this? This is here, what is the range of v? You know, the range of v is from 0 to u because of this restriction. So you integrate from 0 to u, then 1 by 2 e to the power of minus u plus v by 2 dv, and on integration you will see that this is the result of the integration, that is fu of u e to the power of minus u by 2 1 minus e to the power of minus u divided by 2 for u 0 to infinity. Okay, here there does not exist v, therefore you can take the range of u as 0 to infinity, and this integration is a very simple integration, so I leave this for you. Similarly, marginal PDF of v is obtained as fv of v integral over u fuv of uv du, and you can see that the range of u from this expression, you know, u is ranging from v to infinity, therefore you have to take the integral from v to infinity 1 by 2 e to the power of minus u plus v by 2 du. That is equal to, on integration, this is very simple to integrate, and then you will see that this is e to the power of minus v equal to 0 elsewhere, and what is v? V varies from 0 to infinity. You need to take the quantity u here. Okay, now these are the things how you obtain the marginal distribution of u and marginal distribution of v. First, you find the joint density of u and v, and on integration, you can separately, individually find the distribution of u and distribution of v. And this is the procedure. Okay, and you see in this example, you have given the random variables x and y whose joint PDF. Here the joint PDF is given. And sometimes in some questions, you will have the, you will not have the joint density, but you will have the distribution of x and distribution of y separately. And if these x and y are independent, you can find the joint distribution, joint density by multiplying the marginal density of x and marginal density of y. We will do more problems of this kind and other in the next video. Okay, thank you.